I'm here at our garage transformation project, and this is the project I was mentioning in an earlier video that the homeowner was really complaining the house was super drafty. So we're very interested to see just exactly how leaky the house is, and I've got the blower door set up, so let's check it out. So a blower door is a pretty simple concept. It's basically a large fan connected to a pressure gauge. This red hose is connected outside to measure the exterior pressure, and then the yellow hose measures the pressure inside the house. And what it does when we turn it on, it sucks all the air out of the house, creating a low pressure condition in the house and causing the exterior relatively high pressure air to come in through all the gaps and cracks in the house. So wow, this house is super leaky. So for context, our goal that we're going for with this project and the current Dallas requirement is 3 ACH 50. And we were scoring somewhere between 15 and 17 ACH 50. So house leakiness is measured in what's called air changes per hour at a certain pressure level. And so the standard pressure level is measured in pascals, and we set it at 50 pascals of pressure and then measure how leaky the house is at that constant pressure level. So blower door testing got started in the 70s during the energy crisis. The first blower door appeared in 1977 in Sweden. It was basically just a fan and a window they were using to measure the leakiness of a house. By 1979, researchers at Princeton University were using door-mounted units, similar to the one that I have now, but much heavier, to measure the leakiness of houses in New Jersey. So why does this even matter? Well, a house that leaks air leaks energy, and it also affects the felt comfort of a home if your house is very leaky. So building a tight house with a low blower door score will be a house that uses less electricity. Also, less external contaminants will come into the house, such as pollen, dust, and things like that. But you can go too far. The thing you have to be careful of is as you make the house tighter, if you make it too tight, then you can create a situation where the internal air quality gets stagnant and becomes unhealthy. So the motto is build tight, ventilate right. So when we build a tight house, we also incorporate a fresh air system so that we can let enough fresh air in on a controlled basis to keep the internal environment of the home healthy. So house leakiness or tightness is measured in what's called air changes per hour, or ACH, at a constant pressure level. The pressure is measured in pascals, which is a unit of pressure, and the standard pressure level for home air testing is 50 pascals. So this home in its current condition is measuring roughly 16 air changes per hour at 50 pascals. So the standard 50 pascal pressure difference measurement that we use simulates wind and stack effect, and 50 pascals is roughly equivalent to a 20-mile-an-hour wind. Right now, this home is roughly 15 to 16 ACH 50, and our goal when we finish construction is going to be 3 ACH 50. If we took all the little leaks in this home and combined them into a single location, so let's say we sealed the entire home and there was just one place that was leaking, a house that is 15 to 16 ACH 50 is equivalent to having a hole in the wall that is 2 feet wide. So we're going to get this house down to 3 ACH 50, and that will take that 2-foot wide hole in the wall and turn it into about an envelope size hole in the wall. So passive house standards for air leakage is 0.6 ACH 50, and our Rocky Creek project is currently 0.5 ACH 50. And for context there, that's equivalent the entire house to having only a hole in the wall that's 3 to 5 inches.